Hello and welcome to Sean White's Solar and Energy Storage Podcast. Last week was PV Safety Basics Part 1, so guess what? Yep, that's right. It's PV Safety Basics Part 2. Some of the things that we're going to talk about here is the most misunderstood PV label that starts out with terminals on line and load side may be energized in the open position. Yes, open, that means off with electricity. We're going to talk about DC and AC disconnects, capacitors, PV being on when the sun is up, pocket voltage indicators, hot stick voltage detectors, and these pocket voltage indicators and hot stick voltage detectors, they only work with alternating current, so be careful not to use that or trust it with DC current. We're going to talk about Lockout Tagout, otherwise known as LOTO. We're going to talk about material safety data sheets, otherwise known as MSDS, the 6-foot fall protection rule. We're going to cover guardrail fall protection, safety net fall protection, personal fall arrest system fall protection, also known as PFAS. That's the popular one that we use for solar, and that includes an anchor, a harness, a lifeline, and a shock absorbing lanyard. We're going to cover ladders, fiberglass versus aluminum ladders. Fiberglass does not conduct electricity. We're going to talk about working around power lines, 3 points of contact when climbing a ladder, tool backpacks, and also there's something called a self-retracting lifeline, which is also known as a Yoyo, and sun exposure. That's right, you don't want to get skin cancer, do ya? I always consider my sunscreen safety equipment. So to learn more, go to solarsean.com. So on with the show. And first here, what we're going to talk about is what I figure is the most misunderstood PV label. Okay, let's look and see what this says right here. Warning, electric shock hazard. Do not touch terminals. Terminals on both the line and load sides may be energized in the open position. So what this means is line and load. That means both sides of a switch. So if you have a light switch, the load side is going to your light bulb, the line side is going to your utility. And then when you close that switch, that means you turn it on, you close the circuit, and then the electricity comes from the utility and it circulates in a circle, pretty much. And then when you turn that light switch off, what happens is on the light bulb side, it's safe, you can touch it and all that stuff. And then on the utility side, it's still dangerous. But with an inverter, what happens is, let's say that you have conductors going up to the solar modules up on your roof. And if you have just one disconnect in between the inverter and the solar modules up on the roof, and then you open that disconnect, open means off, and you open it up, it's going to be energized from the rooftop because the sunlight is shining on the modules. And so when I say energized, it's going to have voltage, not current. That's when you open it up, that's when you can disconnect the connectors up on the roof because there's no current running through and you're not going to see an arc. So you open it up, but there's still voltage there. And so if you touch two wires, then you can make a circuit again, like from the positive and the negative. You've touched positive to negative and it can make a circuit there. So there's voltage there. And actually, the voltage goes up by 25% when you turn it off on the PV side. And that's because if you look at what's called an IV curve, you go from operating voltage to open circuit voltage, which is off, which is about 25% more voltage than when it's on. And so that could be a little bit of scary and that could potentially make a spark, and people have been hurt dealing with that. And you need to be careful, and you don't want to touch those two wires and complete the circuit. You want the inverter to complete the circuit, not your fingers or your heart. And so we know that it's dangerous on the PV side. But what about the inverter side of a DC disconnect? The inverter side of a DC disconnect can also be dangerous for 5 minutes. And so inverters have something in them that helps process the power called a capacitor. And a capacitor is something that's like two different plates, and one of them has all the electrons on it, and all those electrons want to balance out and go to the other side. Then they take those two plates and they roll them up so it looks like the shape of a battery. And it's called a capacitor. And if you took the cover off of an inverter, you see a bunch of them in there. And it helps smooth out the power. They say it kind of has a filtering effect when they're making sine waves with DC power. And so there's those capacitors in there, and they hold energy. Some capacitors can hold energy for long periods of time, like for weeks. But the capacitors in the inverter, by the rules that they test the inverter to, have to self-discharge within 5 minutes. So after 5 minutes, there's nothing left in the capacitor. But you should also always check to double check when you're working with something. So you turn off this disconnect, both sides of that disconnect are going to be dangerous to touch. And one side, while the sun's up, it's still dangerous. And the other side, while after 5 minutes after it's been turned off. And I shouldn't even say on the PV side when the sun's up, because even when the sun goes down, you can get voltage from moonlight, lights, bright light shining on something. And even people have been hurt by flashes of lightning causing light to energize the PV system and knock people down. So be careful. Especially when you're on a roof, always wear fall protection. And the DC disconnect, when you disconnect it, it still could be energized on both sides. And that can also happen for charging batteries too. With PV systems, you have things going different directions. But on the AC side of the inverter, on the alternating current side of an inverter, don't have this problem. Because the AC side of an inverter has to do something we call anti-islanding. And so if you open up an AC disconnect, on the inverter side, it immediately goes to nothing because we would have never been able to put solar on the grid if it was going to feed the grid after you turn it off. They make grid-tied inverters, so it's just impossible. They cannot feed the grid when the grid is down. They go automatically, immediately, right to 0 volts when you disconnect them on the AC side. So you don't need this sign on the AC side. However, in some places they still say that you do. So that's places that just don't really understand solar. They were telling us that in the Philippines when I was doing classes there. They have a book, the Philippine Electric Code, that is almost exactly the National Electric Code. I tell them that we copied the Philippine Electric Code. They think that's funny. PV is on when the sun is up. The sun is up, you disconnect everything, you turn it all off. It's still on when the sun is up. And what are you going to do? Wait for nighttime? Some people will even try to put, and it tells you can do that in the NEC, to put an opaque material over the solar modules. I don't trust it because even if you put something over the solar modules that is a tarp, some light's going to get through and it could still shock you. And so pretty much what you do is you open up the disconnect, you turn the disconnect off, and the connectors that go between the modules, then you can take those apart. And those are well protected, and it's not going to arc across if there's no current going through it. And that's how you take apart a PV system when the sun's out without putting big tarp over the PV modules. You can still put tarps over it. I don't have a problem with that. But most people, what they do is they turn off the disconnect, then they disconnect the connectors. And not just disconnect, turn off everything. It's like, don't ever work on any disconnect that's not turned in the off open position. Digital multimeter, it's also called a clamp-on ammeter, we can use to figure out what's going on with a PV system. It can measure current without touching a wire. It's kind of cool. And there's different kinds, and some of them work just for AC, and some of them work for DC and AC. And so one of the things you want to do with your meter too is before you do anything, inspect the meter. You always do that subconsciously without even thinking about it. And so what I mean by inspecting the meter, look at it, make sure it hasn't blown up, that it's not on fire. That's inspecting, making sure it's not on fire, making sure that the wires that come out of the bottom, there's usually a black and a red that come out that you touch on things, that they are like not bare wires, that they aren't broken, so on and so forth. There's also something called a pocket non-contact voltage indicator. And it's this little thing, and you touch a wire and it tells you if there's voltage there. And it does not work with DC. It only works with alternating current. Another thing that firefighters use is called a hot stick. It's the same thing, but it's just bigger. They can use it with a stick where they don't have to get so close to something. And they might put it up next to a wire and go like, oh, that wire's safe. But if it's direct current, it's not safe. And so turn off all circuits before working on it. Also, if you're checking for DC, just remember there's lots of things that only work for AC and not for DC. And most electricians don't work with DC. They're just working with AC, and they might not have the equipment to measure the direct current. Thing about less expensive meters, if you go get a real cheap one, you can buy a voltmeter for $10. It's not going to last that long because you can have them on the wrong setting and they won't blow up. Other meters, you put them on the wrong setting and all this current goes through it and boom, it blows up. So don't do that. Gloves. And so if you're working on stuff, it's good to wear gloves. So if you accidentally touch a wire, it doesn't go through your heart. And then you have to go to the hospital. That's another thing about OSHA. If you ever get shocked, even if it's a small shock, according to OSHA, you are supposed to go see a doctor. Not everybody does if they get a little small shock, but that's what you're supposed to do. Some tools. And I always ask my class, like, how many of you electricians use insulated tools. And so I had a bunch of electricians in my class this week. I was teaching actually some apprentice journeyman electricians solar class this last week, and none of them do. And so those guys said, oh, they're too expensive, but it's a good idea. And every once in a while, somebody does use these insulated tools because they want to live for a long time. Okay, lockout tagout. Also, they just say LOTO, lockout tagout. Lockout tagout equipment, all different ways to lock out and tag out things. They even have some that can go over a connector on a module so somebody doesn't go plug it in. And the rule about lockout tagout is the only person that may take it off is the person that put it on. So right before you ask for a raise, put a lock on and go like, if you fire me, this job will never get done. It's a joke. And it's got a tag, got the person's name on it. Sometimes they'll even have the person's picture on there. OSHA, Occupational Safety and Health Administration. I believe in Canada, it's Occupational Health and Safety Administration. A lot of different countries have something just like this, and they probably all copy each other, and they're very similar. So it's also the very exciting Volume 29 of the U.S. Code of Federal Regulations. And so we're going to have state standards. Sometimes there's like Cal OSHA, state OSHAs, and the state standards must be at least as effective as the federal. So you can't have a state standard that's more lax, but it can have extra requirements. Canadians, they have provincial occupational safety and health rules. And if you're a Canadian, you can check that out, eh? Canadians are North Americans, and so they can take the North American Board of Certified Energy Practitioners exams, NABCEP. Okay, have a safety plan, assemble your workforce, have safety meetings, know the area. Also MSDS, that stands for Material Safety Data Sheets. And that goes with like different materials, like especially like toxic materials and things. You should have those things on site. And then also, what's the number for 911? I'm trying to remember. You should also have all this emergency procedures and so on and so forth. Falling is the leading cause of death in the construction industry. And so a shock on a roof can cause a fall. Anytime you take any kind of test that has anything to do with solar or construction or anything, they're going to give you the 6-foot question. And that is 6 foot is the limit of fall protection. So if you're above 6 feet, you need fall protection. And also, though, speaking of Canadians, it's 10 feet for those guys. But that's because they play hockey. 6 feet fall protection. Don't forget. Do you remember? 6 feet fall protection. That's going to be on your test if you take a test. Different types of fall protection. We have guardrails. And so that's putting like a railing around a building. We have safety nets. That's for clowns at the circus, but also especially safety nets are used for tall buildings, like if you're on a skyscraper, because not only if you fall, but if you drop a screwdriver, it can impale someone down on the ground. So the safety net can capture all your nuts and bolts and everything. But most of the time in the solar industry, people will use the Personal Fall Arrest System, PFAS, and it consists of an anchorage, and so that's the thing that attaches to the roof, screws or a nail, and it can be able to handle 5,000 pounds because it's a big shock when somebody falls and it goes snap. And so that's 5,000 pounds. That's like a car. Then also there's a Lifeline or a lanyard, and they have body harnesses for fall protection, and that's what most people use. And so ladder accidents happen at the top of the ladder, 900 deaths per year, 100,000 injury accidents. So that's a lot of people getting hurt on a ladder. I've seen somebody get hurt on a ladder right in front of me. Half the accidents with people carrying something in their hands. That's 11 billion a year. I would sure like to have that. The steps, 10 to 14 inches apart. That's a foot, plus or minus 2 inches. And 3 feet above the top of the roof, tie the top, 1-to-4 ratio. Just remember all that. And then another thing too is aluminum ladders conduct electricity. And so if an aluminum ladder conducts electricity, why not use a fiberglass ladder? And so that's like the type of ladder electricians recommend are fiberglass ladders. But you know what? Fiberglass ladders do have aluminum steps. The one thing you don't want to use is a ladder that's painted because it could hide the cracks. Stay 10 feet from power lines. And so stay 10 feet away from those lines and keep your solar rails 10 feet away from those lines. And always use the proper ladder for the job. So an A-frame ladder, that's not what you use to climb on a roof. You're not supposed to do an A-frame ladder onto a roof. You use an extension ladder. There's things at the bottom of ladders that can even out with the ground and keep 3 points of contact on a ladder. So you have 4 points. You have 2 hands, 2 feet. And so try to only move one of those things at a time. 1 hand and 1 foot at a time. 1 hand or 1 foot at a time. The way of dealing with that is putting all your back tools in a backpack. And so that's one thing that I do. I like using backpacks and having free hands for a lot of things. And there's special tool companies that even make backpacks. You can find them in electrical supply stores and hardware stores and so on and so forth. Fall restraint system. We also call that a PFAS, personal fall arrest system. And then some guys use something they call a yo-yo. I had a guy in my class last week talking about yo-yos. So if you hear somebody talking about yo-yos, instead of having shock absorbing lanyard and rope, it is just something that has typically like a steel cable. It just rolls out like a yo-yo and then it springs right back in. And they're more expensive. Harness. And if you wear the harness too loose, it can hurt you when you fall. And so wear the harness tight if you don't want it to hurt you when you fall, or your voice might sound like this if you don't wear it tight enough. The anchor, and so they have a little bit of warning on it. One interesting thing about anchors is some of the solar installers are like, should we leave it on the roof for maintenance and all that kind of stuff, or should we take it away from the roof? There's different theories on what to do, and they both make sense. So to leave it on the roof, obviously, people are going to be able to use it when there's maintenance, and then you don't have to take it off and flash the holes and all that kind of stuff. And it's like you put it on the roof and you save time when you don't take it. And so that's leaving it on the roof. But then the attorney reason not to bring it up on the roof is what happens if 20 years later somebody tries to use that and it's 20 years old and it breaks and somebody gets killed. And so that's the attorney reason not to leave that on the roof. A shock absorbing lanyard, it's like a strap, sort of like a seat belt of your car, and it's all wound up. It just goes over, wound, and then it's wrapped in a tight plastic. And so what happens if you fall, like the hangman type of fall, and it goes snap, it kind of lets you out slow so it doesn't snap you so hard. Can you imagine even falling 6 feet and then going snap? That could kill you. That could give you whiplash. Hangman. Like, so if I ever stole a horse and they were going to hang me, my last wish would be one of these, and then I would be like Clint Eastwood and I'd survive. And so this thing will break the fall. Even if it was 1 foot, it could snap you pretty good. The rope or the cable, always use the shortest rope possible. Remember, don't use one that's too long. Some people will even put a knot towards the edge of the roof to know what's going on. So use the shortest rope possible. Okay, so this is my theory. What the number one cause of death from installing solar is going to be in the long run is going to be melanoma, skin cancer. Kills a lot of people, even without installing solar. So we're putting solar up on the roof in the sunlight where there's no shading. And so what happens is we're just in the sun all day long. And all solar installers know no matter how much sunscreen you wear, you're still going to get a tan. Also, the thing about skin cancer is it happens so slow and they don't know where you get it from and all that. It's the one type of work injury that's not covered by workers' comp. Okay, that brings us to the end of the safety segment. So just don't forget, 6 feet fall protection, 1-to-4 ladder ratio, 3 feet over the top, lockout tagout. You're set. You're ready to pass all the safety questions on any easier NAPCEP exam.
Thanks for listening to Sean White's Solar and Energy Storage Podcast. Now you are safe. You listened to Safety Basics Part 2, and if you want to learn how to be safe or how to not be safe, you can just listen to this in reverse. But I suggest going to solarsean.com, that's solarshawn.com, to learn more about everything under the sun.